Hello and welcome once again, guys. Let me ask you one question. If you see maybe an expression 5 raised to the power 4, what idea comes to mind? Or what comes to mind? Can you tell us? So, what we are going to do is you need to relax and do not let anything distract you for the next 20 minutes. What you need to do is just focus on this particular lesson, and then when we are done with the lesson, you'd come to know, or you come to realize and understand or gain a deep understanding of what we mean by 5 to the power 4. Now, in today's lesson, our focus is going to be on a new topic. In the previous lessons, we were discussing the topic sets, but now we are done with that particular topic, so we are moving on to the next or a new topic. And this new topic is what you can find on the board: indices. So we are going to be talking about indices in this new lesson. Now, if we talk about indices, what does it mean? So supposing we have an example of the form a to the power maybe 2. What name is given to that expression? Yes, it is an index, or in a plural form called indices. So whenever we write a number with a base, say a, and to the power or the index, maybe say 2, then we call it an index or indices. So we have an example on the board: 5 to the power 4, which depicts what we are talking about: indices or an index. Again, when you see an expression of the form x to the power, say 7, multiplied x to the power 3, again, an expression of the form x to the power 3 multiplied by x to the power 7, what is it? It's the same as an index or indices. So in this particular lesson, our major objective will be to gain a deep understanding of how to solve problems involving indices. All right. So let's begin. So with indices, I just explained that it is normally in the form a raised to the power, it could be whatever number, 1, 2, 3. So let's take a look at a real example and then see how it is worked on. If, say, you have an example, maybe 2 raised to the power 2, like you can rightly see on the board, 2 raised to the power 2. What does that mean? So 2 raised to the power 2, 2 is trying to tell you that 2 is multiplying itself by a particular number of times. So the power is telling you, the power 2 is telling you that the base 2 is multiplying itself twice. So as you can see, 2 raised to the power 2 can also be expressed as 2 multiplied by 2. So we are just trying to say that if you have the base, which is the number 2, the power is telling you how many times the base is multiplying itself. Let's take a look at another example. So we have another example, 3 raised to the power 2. What does this mean to? Just try. Yes, I agree with you. This also means that the base 3 is multiplying itself how many times? Yes, the number of times it's raised to the power, so which is 2. So meaning that the base 3 is multiplying itself twice. And hence we can have the expression 3 multiplied by 3, which is appearing twice. So that's what it basically means. So can you give an example of an index or an indices expression? You can try writing that on in your exercise book, and let's see. So let's take a look at another example if you finish doing that. So how would we write the expression 5 raised to the power 3? So that means that we are going to have 5 multiplying itself how many times? 3 times. So that's exactly what we are going to write. So we are going to have 5 multiplied by 5 multiplied by 5. So the first 5 meaning 1 time, the second 5 meaning 2 times, and the third 5 meaning 3 times. So 5 is multiplying itself 3 times. So always you need to focus on the power. The power is telling you the number of times the base is multiplying itself. So that is how it is dealt with. So let's try an example and then see if you can grasp whatever we are talking about. So this is an example for you to try on your own. Give you some time to complete it. So try expanding the expression 2 raised to the power 4. Try expanding the expression 2 raised to the power 4. You can pause the video and then try. Then when you finish, you continue. Again, feel free to always focus on the power. It is telling you the number of times you are multiplying the base by itself. Do you have an answer now? I can agree with you with the answer you've gotten. So we know the base is 2, right? And then we know the power is 4. So that means that we are going to multiply it, the base, which is the base, by 4 times. So we are going to multiply 2 by 2 by 2 by 2 4 times. So that's what we have on the board here. 2 multiplied by 2 multiplied by 2 multiplied by 2. So this gives us a full expression of 2 raised to the power 4. So what would the answer be now? Now we are looking for the actual answer. 2 multiplied by 2 is 4, right? So on both sides, it's 4 multiplied by 4, which is going to be 16. So that means that 2 raised to the power 4 in effect is going to give you an answer of 16. So we know 2 raised to the power 4 will give us an answer of 16. Now let's look or take a look at another form of indices or another example, and then see how we can expand such an example. So this is another example that we would like you to pause the video and try on your own. 3 raised to the power 3. Expand the index. So okay, so we have 3, which is the base, being raised to the power 3. So that means that you're going to multiply 3 by itself how many times? Yes, 3 times. So let's try expressing that on the board. So we are going to have 3 multiplied by 3 multiplied by 3. So when you count the number of times 3 is multiplying itself, it's 3 times. And then what would the final answer give us? The first 3 multiplied by 3 will give us 9. And then 9 multiplied by 3 will give us 27. So the answer for 3 raised to the power 3 will be 27. So the answer for 3 raised to the power 3 is going to be 27. So that is how to expand an index, or when you are given indices in this form, that is how to expand it. Now we want to take a look at some laws or some basic laws of indices. We want to take a look at some basis or some basic laws of indices. So let's first take a look at law 1. Let's first take a look at law 1, what it means and how we can apply it. Law 1, what it means and then how we can apply it. So you can see with the first law, it says that when you have an expression a raised the power m multiplying a raised the power n, the answer should be a raised the power m plus n. And you should always remember that the bases should be the same. The bases should be the same. Realize that on the board we have a as the base on the first side and a as a base on the second side. So they should always be the same before you can apply this law. If the bases are not the same, then this law does not apply. I repeat again, if the bases are different, you cannot apply this law. So let's take a look at an example. Supposing we have a raised to the power m multiplying b raised to the power n, we cannot have the answer being a raised to the power m plus n. That is because the bases are different. We have a and b as our bases, and it cannot be accurate. So always the basis must be the same before we can apply the law. So this particular one would be incorrect. So let's take a look at an example. Maybe you have an expression of the form 5 raised to the power 2 multiplied by 5 raised to the power 3. So we have 5 raised to the power 2 multiplying 5 raised to the power 3. Now, when you take a critical look at the expression, what is the first thing that you observe? When you realize that the bases are the same. We have 5 on one side and then 5 on the other side. And again, the operation there is not addition or subtraction, it is multiplication. So that means that we have fully satisfied the conditions and we can apply law 1. The bases are the same and it is a multiplication operation. So we can apply law 1 and write 5 raised to the power 2 plus 3. So the first thing is to check the bases if they are the same. And then the second thing to check too is if it is multiplication before you can apply the law. So we are done with law 1. Now let's take a look at law 2. Let's take a look at law 2. And again, you see that we have the numerator to be a raised to the power m divided by a raised to the power n. Is this the same as law 1? They are different. You realize that when you take a look at law 2, it is different in the sense that it is not multiplying, but it is dividing. It is a fraction, it's dividing. So it's different from law 1. So if you have the bases that are dividing each other being the same, then you can subtract. So let's take a look at an example to see how we can apply law 2. Supposing we have the expression 5 raised to the power 3 divided by 5 raised to the power 2. You realize that here too, the bases are the same, 5 and 5. So then with the powers or the exponents, what do? Since it is dividing, then we subtract. Since it is division or it's dividing, then we subtract. So we are going to end up having 5 raised to the power 3 minus 2. So let's take a look at the last law, which is law 3. Let's take a look at the last law, law 3. So law 3 also says that when you have an expression in a bracket, a raised to the power m to the power outside the bracket n, the answer is going to be a raised to the power m multiplied by n. Again, when you have an expression inside a bracket a raised to the power m, and there's an exponent outside the bracket n, the answer is going to be of the form a raised to the power m multiplied by n. So that is what we can see on the board. Now let's take a look at an actual example involving numbers, and let's see. So we have the expression 7 raised to the power 2 in one bracket multiplying the exponent 3. So you are going to end up having 7 raised to the power 2 multiplied by 3, and then the answer we have is 7 raised to the power 6. So please, always, if you want to work or you want to solve problems involving indices, these 3 laws are very, very important. So you need to go over this particular lesson over and over again before you can know how to apply these laws. So feel free at any time to pause the video, go back, and then play it over and over and over again till you gain a full understanding of the topic. I also encourage you to practice more so that you'll be able to fully understand whatever we've discussed in today's lesson. So now in today's lesson, what have we discussed in conclusion? So we talked about the 3 laws involving indices. And we also talked about indices in general. And we are saying that with the laws, we have 3 laws. Law 1 says a raised to the power m multiplied by a raised to the power n. We add the powers. Law 2 also says that when we have an expression a raised to the power m divided by an expression a raised to the power n, what do we do? Do we add? No. We subtract the powers. Then law 3 also says that when we have the expression a in one bracket raised to the power m multiplying an exponent outside the bracket n, we multiply the exponents. So you wouldn't have any problem actually dealing with indices problems if you actually know how to apply these laws. So we would wish to end the lesson here, but I would want to suggest some assignments or give some assignments to you so that you try your hands on them later. So you can actually pause the video and write these assignments down and then try them on your own later. So practice this particular example on your own later. Try to use the steps that we've talked about in today's lesson. We'll end here, and as always, I'm reminding you to like and subscribe to the video. For now, I'll say goodbye.